The new Ollama 3.2 multimodal model has released, and the 3.2 model is essentially a layer on top of the Llama 3.1 model, which enhances the Llama 3.1 model with vision capabilities. Like, it essentially takes Llama 3.1 and makes it multimodal. In that regard, it uses RLHF, or reinforcement learning with human feedback, into consideration to fine-tune the model even further and align it towards the human-like responses. So let's quickly look at the Llama 3.2 model. And the beauty of this is that it's already incorporated into the Ollama universe. So we can test it out using just doing an Ollama run or Ollama pull. So I've already pulled the model. So let's first look at a few images that we are going to analyze. Let's see what kind of images we have in store. Like, I renamed the images so that the Llama model cannot guess the contents from the FineLem itself, and I have stripped off all the image parameters. So let's look at the first image we're going to analyze. So it looks like a lion reading a book, a scholarly lion reading a book with a logo in the background, which is the name of the podcast that I host. So let's see if Llama 3.2 can identify the contents of this image and describe it in detail. Okay, now let's look at how we can test out this model using Ollama in command line. Now, so many people say that directly give the command and run the vision model along with the prompt in the same command line. This used to be true before when the images, when the chat completion mode or the interactive mode of the Ollama couldn't interact with the file system, and it cannot load the files itself to query and interact with them because they are not multimodal. Now these models are multimodal, and I mentioned before that they are RLHF completed, which means they are trained with real reinforcement learning with human feedback. Therefore, they are instruct tuned like Instruct GPT is, and therefore they can interact with the file system. So therefore, although we can do this, we don't need to do this. We can just ignore that and just run the model. And now we can describe the image. Give the command to describe the image, a1.jpg or PNG in fact. And this one will fail. Let's see. It will say I don't have access to external file system. And the reason I wanted to show this, because we have to give the absolute path or relative path. A1.png is ambiguous to the model. It doesn't know where to search for. So I'm going to give a relative path. This file is in the same directory in which I'm running Ollama. So I'm going to give dot, which is same directory, /. So I'm telling Ollama that this file resides in the same directory in which it is running, so it can just search that relative path, which is in the same folder it's running, and then it will be able to access the file, load it, and pass it on to Llama 3.2 for the analysis. And let's see how it works. So it adds the image, and then it describes the image. This goes in quite detailed. Well, not as much detailed as I like. So describe the image in detail. Let's see, increase the detail. Let's see how much further it can go. Let's describe the image in detail. So it can go a little bit more. It goes a little bit more. Let's do extreme detail. Yeah, now it really goes for it. In the background, a chalkboard with the words "math is learning simple." So it didn't get everything. So it got some of it, but not everything. And then it describes in detail. So it passes the first test. It can describe some image. Okay, so now let's look at the next image. What was our next image? Our next image was of a comparison between different voting classifiers, the XGBoost, Random Forest, DNN. These are different voting classifiers that are used for a classification task or a machine learning task. So these are the comparison of accuracy between those different models. So let's see if it can access that. Of course, it can access that. Let's see if we can see that information, visualize, see the graph, and describe the graph. So describe the image in extreme detail. Let's change this to A2. So now it's adding the graph. So box and whiskers plot, that's amazing. It can identify that the plot type was box and whisker plot, and it's a comparison of the cross validation scores for 3 different models: DNN, Random Forest, and XGBoost. Wow, it goes in extreme detail. DNN, the median score is represented by a horizontal line, blah blah blah, random forest. So these details are not as important as human being. We know that we don't need those details. But let's look at the plot and see if it got it right. So yes, it got everything right. It's a box and whisker plot of cross validation scores, and it got everything right. Comparison of 3 different models, and it got extracted the model names. Wow, we got almost everything. It did get the numbers though. Did it get the median values, the maximum and minimum? Let's ask it and see if it can see the maximum and minimum and the median values in that graph. Let's go back and ask it. Okay, describe the extreme detail and see and extract the median and min comma max values of each model. Let's see different models. Okay, so did it find anything? Okay, so the medium accuracy score for the DNN is 0.8. So let's see if it's correct. Okay, 8, it's close to 0.8. It's between 0.8 and 0.85. It's like 0.825. It got close. It didn't get exactly. Okay, median score is 0.82 for random forest. It doesn't even have a median here, so I don't know how it got it. So hallucinated, I guess. And then for XGBoost, it should be 0.8 exactly. Let's see if it got it correct. It's around 0.85. It didn't get it right. It didn't get it right at all. So and it definitely didn't get the minimum and maximum score. So it did hallucinate a little bit and didn't get all the answers correctly. So let's move on to the next image. So this is a more complicated plot. It has 2 charts, 2 bar plots and 1 pie chart, right? So these are comparison of dropout rates after applying the ML pipeline to student retention mitigation, and total deployment cost, savings, etc., is in the pie chart. So let's see if the model can see. Let's first ask what can it see, and let's ask if it can get the numbers. I mean, I'm guessing it can get the numbers because the numbers are embedded. Let's do extract the information from A3. Infographic, definite comprehensive overview performance metric or ML pipeline. First section bar graph. Okay. So first section is a bar graph. Very good. It identified there are 2 sections, and let's see if it got the numbers right because it is throwing us numbers. Okay, that's nice. It got a few numbers right. Okay, dropout rate stands at 80%, where the final rate decreased to 1%. Okay, it got it wrong. It's 11% actually. It's not. Okay, so it got some. It's not hallucination. It just couldn't extract the number 11 because of the horizontal lines that are crisscrossing. Okay, so there was some inaccuracy there. The significant reduction dropout says, okay, it gives some its own thoughts on that. Okay, then 88.5% of total savings. Okay, it extracted that. And okay, so cost contribute to only 11.5%. Okay, that's excellent. So it did get, wow, it did get a lot of ideas, like almost like a human being extracting. So it does have some problem when the numbers are not very or the text is not very legible. Clearly the text is not legible here. Like if I convert this to black and white and increase the contrast, this probably will not even be legible by a human being. So yeah, I can't be too harsh on this model for not be able to read 11 and mistaking it to be 1%. It got close though. Okay, so what else? So I guess it passed on this. There's a lot of textual information in this though. So, but that's the whole idea. Can it read the textual information? And it can see the 2 different charts, and that's commendable. It can see the different charts that are in the part of the same big plot. And then it can see the differences between the bars and extract the information from the pie chart very effectively. So that I'll give it 9 out of 10. Just 1 point for not being able to correctly identify 11%. Okay, let's see what is the next image. Oh, this is a more involved one. This is essentially the machine learning pipeline whose performance chart we just analyzed. So this is a very complicated machine learning pipeline, multiple steps. Yeah, this will be a complicated thing. Even it will take a moment even for a human being to analyze and write down everything. Let's see how the model does. Let's go back. It might need a few steps. So let's change this to A4 .jpg. Oh, we already have extreme details, so it's gonna, wow, it's getting it. It's getting the automated model building pipeline. It's getting the different segments of the pipeline. Wow, this is just mind-blowing. This is just mind-blowing. Okay, let's go back and let's compare with the picture. Okay, so this is the picture. I'm going to put it over here. All right, automated model building pipeline. Wow, this is just insane. Okay, so definitely the pipeline has 4 parts, and it has identified every single part of that pipeline: the automated model building pipeline, the test pipeline, the feedback, and it even got the order right. See, what else did it get? Select model. Wow, it got the select model. It got the train and test portion of the model. We got the model validation. Wow, it got everything. Test pipeline, what did it get? Connect test. Oh, wow, this is mind-blowing. Download artifacts, run PyTest, use cases. Wow, this is almost 99% accuracy. Well, it did mess up the feedback pipeline. I've inserted it somewhere here. Well, I'll say its accuracy is almost 90% at this point. Deploy pipeline, process data, train, test. Wow, it got every model validation. Okay, did it get the NoSQL database that was used? Okay, let me make this, let me see what it says. Model validation. Oh, it didn't say anything about the, okay, let's ask it. Let's ask it if it has any information about the API endpoint or NoSQL database. Okay, let's go back and ask it. Okay, extreme detail, and let's ask it. Once it generates, then we'll ask it. Okay, let's ask it. What kind of database does the pipeline use? Is there an API? Wow, it got it. It got the NoSQL database. Wow, which means it had the information, it just didn't present it. Okay, well, it hallucinated a little bit. Did we use MongoDB for this one? Let's see. Let's go back and check. NoSQL database, we didn't mention MongoDB. Okay, so it hallucinated a little bit. So that's fine. We are okay with that. As long as it knows that we use a NoSQL database, that's fine. There's some hallucination, so it has to be added to a reward model to make sure that, or some kind of fact scoring paradigm pipeline, so which will reduce hallucination. Wow, this is insane. Okay, so those are the four different cases that we saw, from simple to extremely complex evaluation of an extremely complex pipeline and extracting information from an extremely complex machine learning pipeline. So essentially, it can, this Llama 3.2 multimodal model can extract information from flowcharts. OpenAI has a similar multimodal capability, but I'm assuming that will be extremely expensive. This is free, essentially. This you can run this on your own computer with Ollama, and I'm using a GPU. So if you don't have a GPU, it's probably going to take a little bit longer, but still it can use Llama CPP, can do the similar thing, and it can still be run. So this is a game changer. I didn't expect things to get better so fast. This is like almost human level perception. Like, I know the pipeline because I built the pipeline, so therefore I can see the image and instantly decipher it. Like, people who are not familiar with the pipeline or not machine learning engineer, they'll make more mistakes in extracting the information than this software did just here. It's like insane. I'll just give it an A+. It's like it passed with flying colors. It's an amazing set of tool. Go check it out. I prefer using the command line because I just don't want that extra overhead of a chat interface, but you're welcome to hook this up with your GPT-4All or Open Web UI, whatever graphical interface you want to hook up your models, language models with. But I just prefer using Ollama. I keeps it simple. That's it for today.